All right, so for the moment, we got ourselves set up on the bench monitor. So just so we can load Windows here real quick. So we're going to go ahead and kick our machine on. And we're going to hurry up and wait. We're going to cycle the monitor just to make sure it's not being stupid. There we go. Okay, so we're going to jump right into the BIOS real quick. Okay, now, if you look closely, you're going to notice something kind of funny. So right here is, it's going to say 0 gigs. So if we notice up on top here, we've got our EPYC processor, or we've got our board, and that's our BIOS version, our BMC version, which is our network interface. On a Dell, this would be like the AsRock port. HP, I think they just call it the management interface, unlike everybody else. That's basically what that is. So that's the management BIOS, and then that's our processor, our 16-core chip. But with this particular board, processor and RAM combination, for whatever reason, it doesn't detect the memory. However, something funny, if we go into advanced, go our hardware monitor, and it's going to load up all of our sensors. This machine has a lot of sensors on it, and they're just built into the board. But we can look down here at the bottom, and right here it says DDR4, that's slot A, 32 degrees. DDR4 slot B, 32 degrees. Slot E, 32 degrees. Slot F, 31 degrees. That's the RAM. So it's the board is detecting the temperature of the RAM. So the RAM's installed, but it's actually not basically sorta, whoops, that one too many times, not addressing the RAM. This caused a bunch of confusion. I had a support ticket into AsRock for this. Thought we had bad memory, got new memory, still had the same issue. Went and verified which had a support ticket into the memory company that I bought the memory from, or the memory manufacturer, NEMIX. Went and verified that we ordered the exact same stuff that was in the other server that we built. I actually went and opened up that machine. Didn't shut it down, but I just want to verify the labels on the memory. It's identically the same memory, but but that machine has BIOS version 2.3, and this one has 2.6. So evidently, I didn't get real verification of this from AsRock, but it does seem to be that there is a glitch in the reporting to the BIOS of the memory. So we'll see later on. We'll get into Windows after we install, and it will see all the memory, and it will be quad channel supported. So yeah, it's just weird, goofy little glitchy thing. So hopefully they'll come out with another BIOS and it'll fix this problem, and somebody else won't have the same hair-pulling incidents that we went through. So, all right. That's it. Realistically, just leave everything at default on this. If you really want, you can go in here and you can see that all of our boot options are already pre-populated. I've already loaded Windows on this once already, just to count as a test installation, but I want to record it so that way if anybody wants to see how Windows Server is installed, then they can see it. So, alright, so we're just going to go ahead and exit. I'm going to save. And it's going to reload. Takes a minute for it to load the video on these server boards because it's loading so much other stuff. Alright, and we're going to go into our boot menu real quick. That number over on the side where it says BMC IPv4, so that's the management interface. So in this particular machine, if you only have one of the 10 gig network ports plugged in, the management can actually dual IP off that same port. You don't have to have the management port plugged in directly necessarily. Now that is an option that you can change inside the management system separately, so it's that functionality doesn't happen. So it's a little bit of a security check. Okay, so we're just going to go down here and UEFI off our USB. And we're running this off a USB 3 drive, so hopefully this will go a little faster than it did when I initially loaded it. Alright, server 2019, so we're going to go ahead and just hit next, and then we're going to hit install. Now I'm old school, I always do it with keyboard, I don't use the mouse in this. And I always install without the product key, because I don't want it to auto activate as soon as we get into it in case we have hardware issues or anything else. So, but we are going to install with desktop experience. You can install this in standard mode without the desktop experience, and it'll basically run like any Linux server. Me, I'm old school. I like the desktop because it's easier to remote manage that way, because you don't have to set up SSH. You can use third-party software like TeamViewer or go to my PC. In our case, we actually use Avast Cloud Care Business Suite for this. So, but yeah. So desktop experience, and make sure you hit accept. And we're going to do custom. All right. So you can see it. So it's already detected our 4 2 terabyte drives. Now, of course, it's 2 terabytes, but that's the conversion between GB and GBI. So it actually only comes up as 1863 gigabytes, like any other drive. Okay, so this is our current drive 4. So that's the SSD that the current installation's on. So we're actually going to take, and that's our second SSD. So we're going to go ahead and we're going to delete this guy. Oh, gotta hold down Alt. There we go. Alright, now I'm going to have to use a mouse because it's going to be... Oh. Because I can't see the little hourglass to know it's thinking. Alright, so... we're just going to go through and we're going to clear all the partitions off of everything. And what we will do is just a totally clean install and you'll get to see everything. Alright, so we're going to take our drive 4, which will be our SSD in slot 1 of our M.2 slots. And we'll hit next. And away we go. Now, depending on how long this takes, we're going to go ahead and edit it for time. So You'll see Windows go ahead and do its install here, and it'll reboot, automatically boot into setup, and then we'll get to do the initial install part of setup. Some people are probably going to think, it's like, well, why don't you use an answering file during your installations? Honestly, it doesn't take me that long to go through and click through a few screens. So that, and if you get one thing wrong in an answer file, your entire installation will crash. So again, I'm old school. I try not to be too fancy when it comes to certain things sometimes. So, all right. Well, we'll see you in a bit. Okay, and go ahead and reboot, and away we go. So see, the extra funny thing about the whole BIOS issue is that if it didn't have memory, it wouldn't even have loaded setup. So the first time I went through this and I actually got it to load setup, I went, okay, this is weird. It's like, that shouldn't happen. Unless there's some kind of voodoo magic going on with this system, that really shouldn't happen. So, yeah. Interesting side note. I can see JayzTwoCents' face right now. It has no memory, but yet it's loading Windows. It has no memory, but yet it's loading Windows. This isn't possible! It's possessed! No, it's not possessed. It's just the BIOS is being stupid. Fortunately, it's an insignificant part of the BIOS we can just ignore. Restart number 2. You can see with running this with SSD, our boot times become extremely short. That's the one real advantage to the modern servers, is if you can run N.2, especially like this where we're going to run it software rated through Windows, becomes, one, extremely stable, but also two, it becomes extremely fast. If power should go out or anything like that, or you have to do an update and you have to reboot on a production machine, you're not waiting 5 minutes for the dang thing to reboot because it's loading off of mechanical drives. You're waiting at most maybe 30 seconds. So there's still a lot of admins out there that will... Now we do have to put a password here, so we're just going to put my old school default that meets all the criteria. And voila, that's Windows installed in, golly, barely 10 minutes. So there you go. So a couple things we got to do here. So we do have to go through, we've got to load drivers here. So then that way we can load our remote desktop profile, so that way we can remote in, and then you won't have to look at an ugly little monitor. You'll actually be, we'll just record it straight off the remote desktop. So, let's see. Windows Admin Center, blah blah blah. Yeah, we know. This has been around since 2008. Server. Well, this version of it. There was a version of it that was in 2003 R2, but yeah, anyways. Alright, so we're going to go down here. And there's our drive. And we're going to go ahead and we're just going to copy these guys to the desktop here real quick. Alright, so we can get rid of that. And alright, so we're going to load our all-in-one first. That is our chipset driver. Okay. And we're going to extract it. One of these will not load correctly from a zip file. I think it's that one. Pretty sure it's the all-in-one driver. So we're not fully optimized here yet because we don't have Windows updates and we don't have some other stuff installed and running yet. So, but if we go to performance here, there's our RAM, all 64 gigs. So, but yet the BIOS says we don't have any. Well, guess what? So 64 gigs, 3200 megahertz, and we'll actually install hardware info on this so we can monitor our temperatures and everything else. And it'll actually say quad channel support. So fancy, fancy, fancy. Okay, so there we go. Go ahead and set this up. Now, for giggles, we'll go ahead and open up the this guy while this is installing, and we'll just hit express install. Now remember, we're running 16 cores and 32 threads, so we're going to run this little installer, and we're not even going to crack 5%. And then okay, all right, and we're gonna hit close on that because I don't want it automatically updating all the time. Production machines, so like if you had a Windows 10 machine, that would be perfectly fine, but on a production machine, that's kind of a no-no. You really don't want to do that all the time because you don't want the machine to just automatically install an update and then all of a sudden you start having issues with like your network or something else or your Hyper-V or whatever, and things start blowing up. So this is the AS speed. So this is the video driver. You notice we're running 2019. We only have a 2016 Windows Server driver. 16 and 19 are driver compatible. So you can run 16 driver, install 16 drivers in 19 and actually have absolutely no problem. Because in all reality, 19 is just a function update of 16. So there's some Azure functionality and some other things that are installed. In, whoops, that's not what I wanted. Extract. Because this will go ahead and install our Intel LAN Extreme. Because it's extreme, that means it's faster. No, it's 10 gigabit, so therefore it's faster. Even though actually when we deploy this, we're actually not going to be running 10 gigabit out of the box. We're actually just going to be hooking up to a 1 gigabit network switch. So, but future-proofing, as they say, quote unquote. But I'm going to go ahead and stop that. Because for whatever reason, it's hanging up. And it could definitely be because of our chipset not being installed. So, alright, so we're just going to go ahead and reboot, because we're going to need to reboot anyways. And the beauty of a EPYC chip is on solid state is it does all that shutdown process really quick. Even the 8-core that we have deployed not too far from here, it does about the same thing. But the other day when I went and looked at that one, I checked the uptime on it, and that one has an uptime of almost 300 days. So I didn't want to touch it too much. An uptime of almost 300 days is pretty impressive for a Windows server. So it goes to show that one, Microsoft is finally really figured out the server game by this point, and also goes to show that this hardware combination and setup and everything is very robust. Yeah, it is pretty much a set it up and forget it kind of a system, which is ideal from an admin point of view. So, all right. All right, so we're just going to delete that one. And we're going to go back here. And we're going to re-extract it. So there's all of our 32 threads, and you can see that Windows really only front loads the first 8 processors. So you really got to be running something in the background to get it to actually run the other 16 threads all the time. Or I should say the other 24 threads. Windows by itself is not enough to really utilize this chip. That's why if you run a 64 core 128 thread EPYC system, you better be doing something with it other than just demoing it, because that's a big waste of processor. I would imagine the reason why this is taking so long is simply because of the fact that of however the way that Intel has zipped this file, and so it's probably more, this particular file is probably more optimized for Xeon than it is for EPYC. So certain compression and decompression is more optimized for Intel processors than it is for EPYC processors. But at the same time, we're not going to be doing a whole lot of compression and decompression. We're going to be running a lot of Windows 10 desktops off of this machine and using it as just a straight up file server. So we need more of the multitasking capability of an EPYC than we do of the specific task application handling that a Xeon produces. So I'm not ragging on Intel by any meaning of the word, but it is one of those things that Intel has its place, and there are things that Intel does better than AMD, and probably always will do better to some degree. However, there is a lot of things that AMD does a lot better on their systems. Virtualization, multi-threaded workloads, just run way more efficiently on AMD than they do on Intel, and that's kind of always been the case for, since the beginning of Xeon back in 2000. That's kind of always been the case. So all right, it's finally done. Okay, so we're going to go ahead and run our auto run on this. Because Intel wants to run their special little software application to do this installing. Okay. Alright, and we're not running anything for SCSI, so we can leave that off. And you're going to notice our CPU is actually going to clock up. Now, this particular chip has, I believe the max clock frequency is 2.8 gigahertz. So most server chips are actually clocked really low, because you'll notice the idle speed on this is about 1.5. And that's because the faster you clock a chip, the more power it uses. So it makes it so this chip just doesn't use a lot of power. Alright. Okay, there's our drivers. So, alright, so we're going to give it a quick reboot here, just to refresh everything. And then we'll go in and we'll set up our remote desktop. And we'll be good to go. Okay, so to set up remote desktop, you just do it just like any other. So we're going to go into PC properties, and we're going to hit remote settings right here. Allow remote. Okay. And we don't need this guy right here. Hit OK. And we're good. All right. So we'll go ahead and we will catch you on the remote, and then you'll be able to see a little better.